say, let's look at a cube first, and then a balloon that I just mentioned, and then anything else. Change in sales. Yeah. So let's start with 27. A large ice cube is melting. Each side, so this is a cube. And as we know, a cube has all equal sides. So it's melting, it's an ice cube. Each side shrinking by 0.8 centimeters per minute. I stop and I'm going to ask you, what does this mean? So we have a cube, an ice cube, and it's melting, and it says each side is shrinking by 0.8 centimeters per minute. We need to identify what this is. What is given to us? So we have the figure, and we're analyzing piece by piece what is given, and then what are we asked to determine?
Volume.
First of all, if it were volume, it will not have two measurement units. If it were volume, it would have cubic centimeters, right? So if it has two measurement units, it must be what type? What did we always say? Two measurement units, two measurement units, two measurement units. For what?
The rate of change.
The rate of change. Perfect. So it says this is the cube, and its side is melting at a rate of 0.8 centimeters per minute. So then what do I write on this side? So I know what it is that is given to me. Okay, let's just peek at the previous problem. So, well, what can this be? Its side is melting at a rate of 0.8 centimeters per minute. So what do I write here? What is given to us? What did we denote the side by?
Would it be dx over dt?
Thank you very much. That's exactly what it's given to us. The rate of change of the side with respect to time. How do I know? This corresponds to x, and this measurement unit corresponds to t. Excellent. Thank you very much. Let's read on now. Find the rate at which the volume is changing when, okay, this bar means when the length of an edge is 20 centimeters. What am I asked to find? Let's read it one more time. Find the rate at which the volume is changing at the moment when the length of an edge is 20 centimeters. So what am I asked to find?
Is that dy over dt?
If you mean dv over dt because it's the volume, yes, exactly. So since we have volume, dy over dt is fine, perfect, but we have to specify that y represents volume. So that's perfect, but we have to say then that y is volume. If we write dv over dt, we understand from the very beginning. Remember one thing. When we're asked to find something and this word comes into play, or at the moment, blah, 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 whatever follows after these two, or maybe in another way, you cannot use in the problem till we get dv over dt. So that's why we did the technique first. I'm trying to get this page back. So see what we did? We did not look at any of this. This did not exist for us. We were asked to find dq over dt. We performed all the operations, and after we solved for dq over dt, then we looked here and said, hey, what is given after when? When, find this, when, blah, 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 blah. So all these meant nothing to us till the last step when we determined, after we determined dq over dt. Same thing here. Whatever follows after when does not exist for us. Okay. So I have to find the volume of the cube first to differentiate it. I know that the volume will change. I know that the side will change. I know that these two are functions of time, and they are related somehow. But I have to start with the basic formula of the volume of a cube. Can anyone give us the basic formula or the formula for the volume of a cube? With side x.
Is it x to the third?
Excellent. And remember, so let's differentiate. What do I write on the left-hand side?
dv over dt.
Excellent, thank you. What do I write on the right-hand side?
3x squared times dx over dt.
Brilliant, excellent. Okay, so now this is what I'm asked to find. And now I can uncover the when. Okay. When what? When x is 20 and dx over dt is 0.8. Piece of cake. So 3 times 20 squared times 0.8. And this is it. We'll get the number. What is the measurement unit, please?
Centimeters cubed
Centimeters cube.
over seconds.
Yeah, we have minutes. That's it.
Yes.
Awesome. Exactly. Cubic centimeters per minute. This is the measurement unit for the volume. This is the measurement unit in the problem for time. So now let's get this. Okay. And I have 3 multiplied by 400, which is 20 squared, and times 0.8. I don't need a calculator for this, but anyway, 960. And this is it. Not too difficult, but of course these problems can get different. Okay. Okay, so let's look at yes, so let's look at 24. So that's my page 5. 24. Same page, 365. A spherical balloon is expanding, gaining 125 cubic centimeters of air per minute. This is what I'm given first. I have to identify it. If I don't identify it correctly, I will not know how to proceed. A spherical balloon is expanding, gaining 125 cubic centimeters of air per minute.
dV over dt.
Of course, thank you, brilliant, very much. Thank you. Let's read on now. Find the rate at which the radius is changing when, and you know whatever follows after when is disregarded till the very end, when, at the moment when the radius is 60 centimeters. What am I asked to find? One more time, let's read it again. Find the rate at which the radius is changing at the moment when the radius is 60 centimeters.
Would it be dr over dt?
Brilliant. Thank you very much. Good. So I mentioned that the volume, we have to start with the volume of a sphere, is 4 pi divided by 3 times r cubed. So this is our starting point. And yes, we differentiate the left-hand side, we differentiate the right-hand side. What do I write on the left? Anyone?
The dV over dt.
Perfect. Good. Let's differentiate. I bring 3 down and it will simplify. So 4 pi times
Square.
excellent,
dr over dt.
excellent. And now I'm not yet there yet. I have to solve for dr over dt. So I will divide both sides by this. So dr over dt equals this over this. So dv over dt over 4 pi r squared. I got that. Now, okay. When r is 60 and dv over dt is 125. Piece of cake. 125 at the top, 4 pi, radius 60 squared, 3600. We divide and be prepared for the measurement unit. So we have 125 divided by, don't forget parentheses around the denominator, otherwise you'll get a different answer, and times 3600. And I got 0.00276. Measurement unit. Anyone would like to give us the measurement unit?
Is it centimeters per minute?
Exactly. Centimeters per minute. Absolutely. Thank you so much. Perfect. Let's take a look at change of sales. Any questions? Please ask any questions, anything. I know you're not shy, but I just need to ask. Any questions for me? Anyone? Okay, let's look at change of sales, 37. Same page, 365. Suppose that the price P in dollars and the number of sales X of a mechanical pencil are related by 5p plus 4x plus 2px equals 60. So that's the given equation. If p and x are both functions of time, okay, measured in days, okay, so the time is in days. Good. Find the rate at which x is changing when x is 3, p is 5, dp over dt is 1.5. What am I asked to determine? Let's read it one more time. Suppose that the price is in dollars and x is sales, time is in days. This is the relationship we are looking at. P and x are both functions of time, and the time is measured, as I said, in days. Find the rate at which x is changing when. I don't care at this point. What am I asked to find?
Would it be dx over dt?
Absolutely. Thank you so much. Thank you, Tyler. Okay, perfect. Good. So then we know what we have to do. So let's differentiate.